Today we're going to talk about spoil boards and surfacing it. Typically on a CNC machine, they'll use a spoil board, usually made out of MDF. And the purpose of the spoil board is to allow you to pass your bit slightly through the bottom of your workpiece so that you end up with a nice clean bottom cut as well as a top cut. And in order to do that, you have to have a sacrificial material underneath your workpiece. And MDF is a very good product to use for this because it tends to be manufactured perfectly flat, and it's very easy for your end mill to cut into, when you go past the bottom of your workpiece. So as a result, though, after a while, you'll end up with a lot of marks and holes and things like that on top of your MDF board, and it helps every once in a while to take a few thousandths or 20-30 thousandths off of it to clean up the board. Additionally, when you put a board down for the first time, it's always a good practice to surface that board. Even though it's brand new, you wanna surface it. So that it squares the board up to the X and Y axis of your CNC machine. So usually you would only take about 20 thousandths off the top of the board, and by the time it's done, that'll ensure that it's perfectly parallel to the gantry on your CNC router. So in this video, I'm going to show you how to set up toolpath in Vectric for surfacing the spoil board. This picture right here shows a Magnate 1¼ inch surfacing bit, and I will have the link to that in the notes. There's also an accompanying article, the blog post that we have on the website that explains what we're doing here as well. So you can see in this picture there is a definitive difference between the surfaced area and the older used area, and we actually took I think it was 3/16 off because this board was pretty badly mangled on top, so we wanted to clean it up. So you'll still end up with some holes from screws that I've held pieces down with, but for the most part now it's perfectly flat, and the majority of it is cleaned up. Now, another reason I like to use a spoil board out of MDF is I have 3/4 inch to screw into. So if I was doing a job that was repetitive, so maybe I had to do 20 copies of something, I could set up a fence along the left side and the bottom of the machine so that I have a X and Y reference point. So all I have to do is put the blank in against both fences, and it's perfectly registered. So I don't have to keep zeroing out my X, Y, and Z every time. It makes the process go a lot quicker. And it's nice to just be able to screw right into the MDF for that. Another reason I use it a lot when I'm doing 1/4 inch or 1/8 inch plywood. Plywood typically does not lay perfectly flat. It has bows and undulations in it. So what I'll do is I'll actually run a toolpath that drills a few holes into the plywood, and I have it set up so that the holes are not where the actual finished pieces come out of. And so I'll run that toolpath, and then I'll use some short drywall screws, and I'll screw the plywood down to the spoil board, and that way I'm sure it's nice and flat, so my toolpaths work properly for cutting out my parts. This is especially useful if you're doing like CNC puzzles and things like that. Setting up the toolpath for a surfacing operation is very simple to do. I'm going to show you how to do it in Cut 2D Pro, but keep in mind you could use Cut 2D Desktop, VCarve Pro, or VCarve Desktop. The process is the same with all of the software. First thing we're going to do here is create a new file. And I measured the spoil board that I have, which is 22 by 32 inches, and it's 3/4 inch thick. Now, we're not going to cut all the way through, so this number is not really that important, but as a rule of thumb, I always like to put the thickness of the material in. That just avoids me down the road of cutting a corner and forgetting to put that number in when I really should have. So I'm going to put that there. I'm going to set the Z0 to the top of the work material, and I'm going to set the XY position to the center. And what I'll do is I'll measure my board, make a mark from 11 inches on the width and 16 inches, and that'll give me a center point with a pencil, and that's where I'm going to set up my tool when I zero off the machine. So I'm going to click OK, and now I want to draw a rectangle. Now I'm going to show you this two ways. The thought that you might have is that you'll want to set a rectangle up that's the same size as the spoil board, and let me show you what happens. So I'm going to go ahead and I'm going to create that. And I am going to click on that line, the rectangle, I'm going to go to Align Selected Objects, and then I'm going to align it width and height to the material. And you'll notice that the purple dashed line is around the perimeter. Okay, so I'm going to close that. Now I'm going to go over to Tool Paths. I'm going to pin that so it stays on the screen. Now keep in mind, the process you want to do here, the machining path, is a pocketing. Okay, I want to actually machine out the area inside of the rectangle. So I'm going to go ahead and I'm going to click Pocket Tool Path, and I am going to go down. I'm not going to go down a whole lot here. I'm actually going to do a 1/16 of an inch. So 0.625 is my cut depth. And I'm going to set up an end mill specifically for this. Now, what I'm going to do is go into the Specialist tab here, and I'm going to click New, and I'm going to select End Mill, and I'm going to rename this. Let's see, 1 1/4 inch surfacing bit, and I'm going to set my diameter, which is 1.25 inches. My pass depth on this. Now keep in mind, we're going to talk just about the STEPCRAFT machine. Now the power of your spindle may vary, and it does on a STEPCRAFT as well. On this particular one, I'm going to be using our HF500 spindle, but if I was using a Crest, I would have a little bit more power. If I was using a DeWalt, but I want to be careful with this. I want to make sure that I'm not taking too much material off, because what will happen is it'll bog down the bit when it starts to bite in. So in this case, I usually just set my surfacing bit to 20 thousandths of an inch. And I'm going to leave this step over at 40%. Okay, so it's basically going to overlap 40% on each one. The spindle speed, in this case, I'm going to set to 15,000 RPM. That seems to be a good speed to run for this type of bit. And I'm going to set my feed rate to 5 millimeters a second with a slow 5 millimeter a second plunge rate. And the reason is when the bit goes to plunge in to make a depth, I don't want it to just bury it right into the bit. I want it to go in nice and slow so that it cuts its way down. You got to remember that the first pass that cutting bit makes, it's actually cutting the full 1 1/4 out of the material. Each additional pass, it's only cutting 40% of that. Okay, so it doesn't take as much power to do future passes as it does the very first pass. So I'm going to click OK, and now I have a surfacing bit set up. This is telling me to do 1/16 of an inch. It's going to take 4 passes, and that's fine for this. It's not something that I need to do like in a super hurry. I'm going to use a conventional direction. I want it to go around in a conventional pattern, and I'm using the offset. And now the other option is raster, where it'll go back and forth. I like to do an offset where it starts in the center and it kind of spirals out and works its way out. So I'm going to go ahead and normally I would ramp plunge moves. In this case, I'm not going to, because I'm plunging only 20 thousandths, and I'm doing it slowly, so I'm not too concerned about that. Now all I'm going to do here is I can name it, but this is the only tool path, so I'm not really concerned about giving it a special name. I'm going to click Calculate. Now what I want to show you is when you preview this tool path, okay, this is where you may come back and redefine the shape. But see, you don't really notice a whole lot, but if you zoom in to the corner, you'll notice that the corners of the material here are uncut. Okay, so you can see where there's the radius, and that's because the bit is round, and we said we were going to cut along the inside of the line, which goes around here, and essentially that's what I'm doing. I'm going as far into with the end mill into this line until it intersects with this one, and as a result, because of the bit being 1 1/4 in diameter, I'm actually leaving some material there, and I'm just trying to zoom in here so you can see it. That's what's being left behind. So if you want to surface the entire area, you have to make that rectangle a little bit bigger. So what we're going to do here is that's exactly what we're going to do. Now it's 1 1/4 bit, so we're going to go, if you go 5/8 over on the size, you're going to have plenty of room to cut that out. So essentially, basically what I'm going to do here is I'm going to highlight this rectangle, go back to the rectangle tool, and I'm going to increase this number by the diameter of the bit. So we're going to go 23.25 and we are going to go 33.25 and then click apply. And since it was already centered, it's going to stay centered. All right, now we're going to close that and we're going to just right click on the pocket 1 and do recalculate all. Okay, so what that's going to do is just basically run the toolpath is the same, the speeds and feeds are the same. It's just going to recalculate it to the new size. Now we're going to go ahead and go to the 3D preview. We're going to reset the preview and we're going to preview all toolpaths again. And this time you'll notice that in the corners, it's perfectly smooth. It's cut. That's what you want. And the reason being is the end mill is 1.25 inches. So we went past that by half the diameter. And that just ensured now that when the end mill got into the corner here, that you're actually, the end mill's round. So it's gonna go touch this edge and it's gonna completely, this point here would now be in the center of that particular end mill. So that's really all you need to do. And then you'll save this toolpath. So we'll click on that. We're going to save this and do save toolpath to file. I'm just going to put it on my desktop. I'm going to call it surfacing. And that's it. Save it. And now I'm going to go over to the machine. I'm going to zero the bit in the center of the board. I'm going to touch it off there and zero everything. I'm going to load this file. I'm going to run it in UC CNC, and it's going to make 4 passes and take a 1/16 of an inch off of my board, and it'll be nice and smooth when it's done. Now, if this was a new piece of MDF, you wouldn't, a 1/16 of an inch is an awful lot. In that case, all I would do is I would probably just do the 20,000ths, and it'll just do 1 pass. You'll be done, and your top of your spoil board will be perfectly parallel to your gantry. If you're running it at 20,000ths and you notice that there's a spot on the board that the cutter is not cutting, then you're going to have to come in here and add a second pass. So you just do 2 passes and then recalculate the toolpath. It's very, very important to make sure that that cutter is making contact with the spoil board the entire time. If there's a spot where, say, the board is uneven and the one side is lower, you'll notice you're cutting on one side, but the other side you're not cutting. Well, that defeats the purpose. You're still going to have a spot on the spoil board that's not perfectly parallel to your X and Y axis. So you want to make sure that you are cutting the entire board. 20,000ths is usually good if you zero off your bit exactly on the top surface. If your board is off by that much, you may have another problem. Maybe the bed on your machine is off, or something's off, your gantry's off, or you just have a really bad piece of MDF. So that's it. And now I'll show it to you cutting. And if you have any questions, please give us a call at 203-556-1856, or you can email us at info@stepcraft.us.